Hello students, welcome to our next video tutorial. We are discussing sections of solids. As we discussed, we will discuss about the objects prism, pyramid, cone and cylinder. We will solve problems one by one on those objects depending upon different cases, how your section plane is located depending upon location of section plane. So as part of that series, sections of solids, first of all we are going to discuss about prisms. Case 1, section plane parallel to VP. Section plane parallel to VP. I said section plane, it's a section plane. HP, VP. Parallel to HP, perpendicular to VP. You know all this, right? This section plane parallel to VP, perpendicular to HP. Now we are at section plane parallel to VP, perpendicular to HP. Now we will have a object, right? And that object will be cutting by this section plane, which is located at parallel to VP. We will look at this with the help of a question. Look at the question. Question number 1. A cube of 35 mm long edges. A cube of 35 mm long edges is resting on HP on one of its faces with a vertical face inclined at 30 degrees to VP. It is cut by a section plane parallel to VP and 9 mm away from the axis and further away from the VP Draw its sectional front view and the top view. Draw its sectional front view and the top view. See, just analyze the question. A cube of 35 mm. What is the object given? Cube. What do you remember cube? Cube is also one kind of prism. We are having 6 equal square faces. Right? This is the cube which I am showing from 6 square faces. 1, 2, 3, 4, 5, 6. 6 equal square faces. Cube. Right? Of each side, 35 mm long edges is resting on HP. HP, my palm, VP whiteboard, right? It's resting on HP on one of its faces. 6 equal square faces, on any one face it is resting with a vertical face inclined at 30 degrees to VP. Vertical face. How many vertical faces will have this cube? 4 vertical faces. 1, 2, 3, 4. 4 vertical faces. Now he is giving condition what? With a vertical face inclined at 30 degrees to VP. Now when you are looking at this position from your side, vertical face is parallel to VP. Am I right? Vertical face is parallel to VP. But one vertical face should be at an angle of 30 degrees. One vertical face or back one, it should have an angle of 30 degrees. It should have. Now if you are looking from here, up to here we are supposed to draw first projections of solids. Projections of solids, front view, top view. We will discuss section again later. Here, when you are solving the problem of sections of solids, you have to draw the first projections of solids. Projections of solids are nothing but, you remember, drawing its front view and top view. Right? Where you can directly draw its original position, or you have to take step by step. You have to go back and think. Now for this particular problem, right, front view, top view. Will you be able to draw its front view directly? You can't. Why? Because vertical face is diminished, this vertical face is diminished. Top view, true shape. Right? When top view, true shape square, right, as one face of the cube having one side angle 30 degrees from the top view, you can draw its true shape and then its front view. Right? First of all, drawing top view. Top view true shape. At what angle? 30 degrees. See, I'm drawing very small. XY line. Anyway, just taking an angle of 30 degrees. On this 30 degrees, I am supposed to draw square of 35 mm side. Vertical face. Cube of 35 mm long edges is resting on HP on one of its faces with a vertical face inclined at vertical face parallel vertical face incline 30 degrees. Top view. Top view here 30 degrees. I have drawn line. This square. How you can represent it? AB. Oops. A. B. C. D. Outside. Inside. E. F. G. H. Center point axis. You know how to get? Just draw line. Top view. Only ABCDs. O I have just indicated. To locate its axis. Now this is your top view. Right, top view, if I have to draw a dimension here itself. Top view of the projections of solid. Now front view. Nothing but from here I am looking. Front view. From front view is how it looks. Edges, vertical edges. See, I hope you all understand. You remember the concept. Parallel, 30 degrees. This line is 30 degrees. From top view, A, B, C, D. Top square. Bottom, E, F, G, H. Top view I have drawn. Front view. Front view, how many vertical faces you will be easy to see? 1 and 2. 1 and 2. What are those? How to draw? From A, draw a vertical projectile. Drawing vertical. From A, B, C, D. Now when I am looking from here, as per concept of projections of solids, vertical edges, what are those vertical edges? AE, BF, CG, DH. Vertical edges. Vertical. Outside AE, BF, CG, DH. Now when you are looking from here, what edges you can see thick of height? Height how much? 35 mm side height. Cube is also having same height, 35. What edges you can draw? Same. Should I have to use this? 35. When I am looking from here, I can see this clearly. So I have drawn vertical clearly. When I am looking from here, BF, it also I can see it clearly. CG, that also I can see it very clearly. How about when I am looking from here, can I see DH clearly? No. So that is to be drawn as like hidden. Height. How much? Axis. See, here is the center part of axis. You can show it here as part of axis. Just a projector. Axis dash dot. Now here outside A dash, B dash. See, I am not explaining very deeply here because this is concept of projections of solids. You know all this. A dash, B dash, C dash, E dash, G dash, H dash. If you are still inside, if you are just putting brackets, no need, but inside if you are still. Now here this becomes O dash. You observe here bottom should be thick. Now that is projections of solids, which we have done as first two lines of the question. A cube of 35 mm long edges is resting on HP on one of its faces. Resting on HP on one of its faces. Here it is resting on HP, XY line, one of its face, bottom, with a vertical face inclined at vertical face. Which vertical face? CDHG. Vertical face inclined at 30 degrees to VP. Now coming to section plane. It is cut by a section plane parallel to VP. It is cut by a section plane parallel to VP. See, I am considering this as a section plane. Thin plane, thickness. It's a square cutting plane, section plane. Now coming to this location, object is like this. 1, 2. See, AB, FG. This is a part. This is remaining part. This part. It is cut by a section plane parallel to VP. Parallel to VP. 9 mm away from the axis. Axis is where? Here. Here it is parallel, and at the same time he is telling 9 mm away from the axis. See, for this location, here is the axis. On axis, we are keeping it parallel. On axis. Parallel to VP. But he is mentioning 9 mm away from the axis and from further away from VP. Further away from VP means here. 9 mm away from the axis, it may be back side or front side. 9 mm away from the axis is nothing but this plane. When it is like this, away means it may be back or front. So here he is mentioning one more condition, and further away from VP. VP further away towards your side. So axis 9 mm. Now here it is, I have to cut here at this location. Draw its sectional front view and top view. Sectional, if I cut here, what front view will look like? Right? If I cut here, top view, section, top view. Section is, and top view is nothing but it's a section. Remember what are the 3 steps which we have to do as part of our. First one is sectional plane or cutting plane, section plane. Section, true shape. 3 steps, remember what are those? Section, section plane, section plane, section, true shape. Section plane, how to show section plane? Line. How to show section plane as per their standards? Dash dot, dash dot, dash dot, dash, outside thick, inside thin. But here how we have to show? For this object, section plane is 9 mm away from the axis. In which view you can see this section plane as a line? From the front view you can see it as a plane of a rectangle. But in the top view you can see it as a line, right? So how that line will be? Let me use my red. See, this is the center. This is your XY line. From center of the axis 9 mm away means below you have to draw 9 mm. That means what you can do is try to mark a parallel line. From that, try to draw a 9 mm line. Don't know how you will. Here. Nine mm. See, parallel to VP, 9 mm away from the axis. Parallel to VP. Parallel. 9 mm away from the axis. See, this is the axis point. If I try to draw a small line, this is 9 mm. How I have to show? It's form of trace. What trace I will get? Which plane it is touching? Horizontal plane. So horizontal trace H T. See, it's going through the object. So outside object I have to show them as thick. Outside the object I have to show them as thick. Inside object thin. Don't give more thick, just 2 strokes. You have to show the difference. HT 9 mm away. I can draw this 9 mm. Away from the axis. Axis 9 mm away from the axis. Now that is what I have drawn is section plane location. He is asking us draw its sectional front view and top view. Sectional front view and top view. So what I said is next is section, right? When I have cut here, right? See top view, don't get more than I have cut. See, when I have cut this particular place, I have to remove this. When I am looking from top, from this back side part only I can view. That is nothing but section. What is asking us? Top view, sectional top view. How you can show is, up to now whatever the things you have drawn in light, right? Now you are supposed to draw them in thick. See, black I am dominating blue. How I can show you? One more black. From here you can see what are the things I can show you. Double stroke of this line. I am drawing double lines. Some thick lines. Up to here. Up to cutting plane. This is top view. You can see the difference? Top view. Top view, right? Where it get coincided with section plane, right? See where it coincided at these locations. Draw its sectional front view and the top view. I have drawn top view. How to proceed to sectional front view? See, I have cut, I am removing this portion. When I am removing this portion, I need some more points at the coincidence of section plane and object. See, this is the object. When I have cut, see, when I have cut, there is one vertical edge. That vertical edge is nothing but here BF. Removing this, then I will form 2 new points, right? How many points I will form here? 1, 2, 3, 4. See how I have to show is, showing with the help of red. 1. First point is on AB, top, right? Next to 2, outside. BC, 3 inside, 4. I hope you all understand this. When I have cut here, right here, when I have cut here, what happened? These 2 points, 4 points I will come. Bottom is outside, outside what? A, B, C, D. When I have cut here, B gone removed, B gone removed. Now here at this particular location, 1. Here 2, here 1, here 2. When I remove this, coming exactly towards bottom. 1, 2, 3. Here, where is this? B bottom I have A, B, C, D, E, F. F removed. There I have 3, here I have 4. That's what I did. 1, 2, 3, 4. Just as per concept of 3D, this is the notation or denotions. Now, if you have to go for drawing, just try to do numbering at the places of cutting of lines, intersection of edges. Right? Intersection of section plane with edges here. 1 on AB, 2 on BC, 3 you have one more inside FG, 4 one more inside EF. Right? It's not a big tough job, simple. Now, when you have drawn those numbering, from those numbering try to draw vertical lines, because we have to draw its sectional front view. How to draw a sectional front view is nothing but, see, from 1-4 I am keeping a straight line and drawing the projector. Up to front 4. From 2-3 I am keeping a straight line see, from 1-4 I have drawn a vertical line, red line. From 2-3 I am drawing vertical line. Now this vertical line, join them. What forms actually here? 1 is at AB. From here A dash, B dash, these points become 1 dash. 2 at BC, B dash, C dash becomes 2 dash. 1 dash, 2 dash. 3 is at FG, bottom, base, F dash, G dash, this is 3 dash. 4 is at FE, E dash, F dash, here it is intersection, which is nothing but 4 dash. Finally here 1 dash, 2 dash, 2 dash, 3 dash, 3 dash, 4 dash, 4 dash, 1 dash. See, I am drawing box with big thick. You can notice the thick red box, which is nothing but sectional front view, right? See, I can show if it is like this. I have cut, remove, and this is the part. When I remove what part? Flat part, flat with 4 points. Flat part with 4 points. Now this is to be shown something very specific. No, sectional front view you cannot identify clearly with 1 dash, 2 dash, 3 dash, 4 dash. Even if you draw thick lines of double stroke or with the help of your pencil. So sectional front views or true shape of the sections are shown with the help of hatching. What do you mean? The new word, hatching. Hatching is nothing but drawing lines in a particular place in some regular distances, equal distances. Now 1 dash, 2 dash, 3 dash, 4 dash, it's a path where I am hatching. Doing hatching means drawing parallel lines inside the box inclined to the regular shape. Inclined. This is a rectangle box. I have to draw inclined, maybe 30 degrees or 45 degrees. You can fix your drafter, keep that, right? And at regular intervals, not less distance, large distance. At regular intervals, you have to do hatching. You have to draw parallel lines. That's called hatching. Drawing parallel lines at regular intervals inside the box, which is newly formed from the sectional plane. Section plane I have drawn here. HT section. This is section. This is section. Sectional front view and top view. Now true shape, sir. What do you mean by true shape? True shape is coinciding with section. In this case, section plane parallel to VP. In this case, you will get another cases where they will be different. See, I can give a hint that when a section plane is parallel to HP or parallel to VP, true shape will coincide with the section. Sectional front view. Sectional front view are same. This sectional front view and this section is same. True shape is coinciding with sectional or sectional view. This is your final answer. See, I hope you all understand, but you may think that it's a tough. It's not tough. Simple projections of solid we have drawn, top view, front view. Right after that, here it is cut by a section plane parallel to VP 9 mm away from the axis. Parallel to VP. So at what distance? This axis location, you don't know that length. That depends upon your drawing. Right? From that point 9 mm away you have to draw a line which is sectional line like this. Outside thick, HT trace. Placing trace is very important. HT, right, as it is parallel to VP. Parallel to VP means no vertical trace, parallel to VP. HT, where it get coincident, locate the points outside 1, 2, 3, 4. From there draw vertical lines to the front view. They also coincides with top 1 dash, 2 dash, 3 dash, 4 dash. Thick them, outside thick them, top view, finally hatch them. See, simple. Here you have to mainly concern with section plane. This is the section plane. Depending upon location, parallel to VP 9 mm away. Parallel up to here, this is 9 mm. Thick. And draw its sectional front view. To draw its sectional front view and top view, we have to draw its top view. When you are drawn section, you have cut. Already you have divided. You have divided this top view with the help of this section line, this part and this part. This part is to be removed, and remaining part you have to draw it thick. That is top view. Sectional top view. Right? Sectional top view means only this portion. For this concerned front view will be drawn with the help of plotting the points or denoting the points 1, 2, 3, 4 for its vertical faces. 1 AB, 2 BC, 3 FG, 4 EF. From here to its sectional front view, draw vertical lines. The vertical lines here, one is in between AB, A dash, B dash, 1 dash. 2 in between BC, B dash, C dash, 2 dash. 3 in between FG, F dash, G dash, 3 dash. 4 is in between EF, E dash, F dash, 4 dash. Try to tick the box. Whatever the backside projections of solids, they all should be light. Now whatever the sectional top view, now this sectional front view should be thick. To show it in specific, the sectional front view, it should be done hatching. H-A-T-C-H-I-N-G, hatching. Hatching is nothing but drawing parallel lines at regular intervals inside the sectional front view, which are inclined, not parallel to the sides. Remember, for this rectangle 1 dash, 2 dash, 3 dash, 4 dash, you are not drawing parallel lines to the sides. You are supposed to draw regular inclined lines from the sides. So like this. So finally, this is your sectional front view, top view. I hope you all understand. It's little bit typical, right? It's not tough. Try to involve, draw projections, locate sectional plane, draw section, top view, true shape. Here I can give true shape and sectional front view are same. Sectional front view. Clear? As we discuss more questions, you will get more idea what is difference between section plane, section, true shape. I have done best to make you understand. Please go once or twice or thrice. As this is virtual, I can't understand, I can't read that you have understood or not. Right? So, hope you all understand. Still, if you have any doubts, you can ask me at any time. Thank you. Jai Hind.